All right, let's do some imputation. In this example, we're going to use the horse colic dataset. The horse colic dataset describes medical characteristics of horses with colic and whether they lived or they died. There are 300 rows with 26 input variables and one with an output variable. This is a binary classification prediction task that involves predicting 1 if the horse lived and 2 if he passed away. There are many fields we could use to predict in this dataset. In this case, we're going to predict whether the problem was surgical or not, which is going to be, I think, column index 23, making it a binary classification problem. The dataset has numerous missing values for many of the columns, where each missing value is marked with a question mark. When we print out the dataset, we can see the rows in the dataset with marked missing values. Marking missing values with NaN, remember NaN stands for not a number, is a loaded dataset using Python is the best practice. Therefore, we can load a dataset using the readCSV function from Pandas and specify NA values to load instead of question marks. Once loaded, we can review the data to confirm that the question mark values are marked as NaN values now. We can then enumerate each column and report the number of rows with missing values for the column. Tying this all together, you can see the complete example loading and summarizing the dataset listed on screen. We can see that the missing values were marked with a question mark character, and they've been replaced with NaN values. Let's go ahead and take a look at the number of columns in the dataset and the number and percentage of missing values. We can see that some columns, i.e. columns 1 and 2, have no missing values, and other columns with indexes on 15 and 21, have many or even the majority of missing values. Now that we're familiar with the horse colic dataset and its missing values, let's take a look at how we can statistically immute them. The scikit-learn machine learning library provides a simple immuter class that supports statistical imputation. Let's explore how to use the simple immuter function. The simple immuter is a data transform that is first configured based on the type of statistic to calculate for each column. For example, the mean. Then the immuter is fit on the dataset, and it's used to calculate the stat for each of the columns. The fit immuter is then applied to the dataset to create a copy of the dataset with all the missing values for each column replaced with the statistic mean, or the statistic value specified. We can demonstrate its usage on the horse colic dataset and confirm it works by summarizing the total number of missing values in the dataset before and after the transform. The complete code is listed on screen. When we execute the code, it first loads the dataset and reports the total number of missing values in the dataset as 1605. The transform is configured, fit, and then performed, and the resulting new dataset has no missing values, confirming it was performed as we expected. Each of the missing values was replaced with the mean value for the column.